Hello everyone, today we will discuss 10th class physics first chapter, reflection of light at curved surfaces. In your 9th class you read about reflection of light on plane surfaces, which is our regular mirrors. But here in this chapter we will be using curved surfaces. That means the surfaces will be like this. So if you observe carefully, these two pieces are taken from a sphere. If I cut this part of a sphere, I'll get this shape. And if I cut this part, I'll get this shape. If I make this shape into a mirror, then these mirrors are known as spherical mirrors. Why? Because these two mirrors are taken from a sphere. Now, our spherical mirrors are of two types. One is concave and other is convex. Now, how do you remember what is concave and convex? Concave, how do we have a cave? Like this. Here empty space and here all stones. So, this is generally said to be a cave. That's why this is coated surface that is represented by dotted lines. And this, from here we can have our reflections. So, this is known as concave. Now, similarly opposite, here it is coated and the reflecting surface is this side, and this is known as convex. Simple topic. So, if you remember concave and convex, now let us see a little introduction of these two types of mirrors. First, I will go with concave. So, let us see about concave. So, what is a concave mirror? It is like this, in the form of a C. Inside we can reflect. So, that means outside surface is coated. Coated surface is represented by lines. Now, we know that this concave mirror is taken from a sphere. So, if I see the whole sphere, I will have the center over here, right? Somewhere here I will have the center. So, this one, only for the mirror if we consider, this is known as center of curvature. Okay? And the center of this mirror, this length center if I consider, then that is represented by P. P means pole. We call this as pole. Center of the mirror is pole. Center of the sphere is center of curvature. Now, if I join these two lines, I am getting one axis. This axis is known as principal axis. What is that axis known as? It is known as principal axis. Now, if I take the midpoint of from P to C, if I take the midpoint somewhere over here, that is represented by F, which is known as focus. So, to make your diagram easier and further also to get our correct answers, make sure that you will take PF is equal to FC, because this focus is the midpoint of P and C. Now, what is the use of this focus? Anything which is reflecting, any light reflecting on the mirror will pass through focus. I mean, the point of intersection of any two lines is passing through focus. Like this, these two lines will pass through focus. That is known as midpoint. And this also we have some rules that we'll discuss in our next class. And this one here we'll just discuss about the basics. So, for now you remember, reflecting lines are passing through focus. Focus is the midpoint of P and C. Now, this is about concave, a general little introduction of concave. Now, let us discuss about convex mirror. How is a convex mirror? It is like this. Inside surface is coated. Now, convex mirror will be a little bit confusing, but if you observe clearly, this is also very easy. Now, here what is the sphere? This one. So here is the center of the sphere. If I remove the sphere, what will this become? Yes, I told you it is center of curvature. Now second thing we wrote about P. What is P? We discussed already, it is the center of the mirror P. All the values are same, no need to worry, all the values are same. This is known as pole. Now if you join this pole and the center of curvature, you will get one axis which is very good. It is principal axis. Now what is missing? Focus. Where is focus? Focus is the midpoint of P and C. That point is known as focus, or it is also known as focal point because it is a point, it is a focal point. Now what is the difference here is, this is the reflecting surface. So light will reflect like this, and imagine it is passing through F. Now from here, based on different conditions, we will have different figures. So the image will go like this. This one we'll discuss in next class. Why is it going like this? In what conditions? In which directions will the ray reflect? And all we'll see in the next class. Thank you.